All right, this is my third take for this video. Welcome back to nuclear chemistry. So we're gonna conclude. There's just a couple more things I want to mention about nuclear chemistry. We're gonna start talking about radiometric dating. So the idea behind radiometric dating is that using radioisotopes, we can trace the origin of objects, right? In like archaeological artifacts or things, right, within geology or even within living organisms. And there's something called carbon 14 dating where they specifically are able to date the origin of objects using carbon 14. And it's interesting because carbon 14, there's only trace amounts on Earth, right? I think carbon 12 is the most abundant isotope or type of carbon that exists. So this is how carbon 14 is formed. You have nitrogen that reacts with neutrons from cosmic rays in space. And this generates carbon 14 by releasing this proton as well. So an interesting application of carbon 14 dating is through the discovery of the Dead Sea Scrolls, where carbon 14 dating showed that these Dead Sea Scrolls were written or copied on paper from plants that died right within a particular time period. The reason I say that chemistry meets religion as the title for this slide is many of you may have heard of the Dead Sea Scrolls, but if you haven't, look it up. It's um it's essentially religious texts that were found, and it makes up some of the foundation of some of our religious texts like the Holy Bible. It has been uncovered or discovered through these Dead Sea Scrolls. So here's an application of, right, where something like religion, archaeology intersects with chemistry through carbon 14 dating. So that's really why I want to mention it here. So let's talk about nuclear transmutation, right? When we looked at chemical reactions, chemicals undergo, right, molecular transformations. Whereas in nuclear chemistry, the nucleus undergoes transmutations. So this involves a conversion of one nuclide to another, right? Because a nuclide is not necessarily being changed, it's actually being converted to some new form. Nuclear transmutation can occur by radioactive decay of a nucleus, or it can react with the nucleus of another particle. So we're going to look at these two types of nuclear transmutations next. An example of this is the first human-made nucleus that was produced in 1919 by essentially taking these high-speed alpha particles and like bamming them into these nitrogen atoms and from that forming oxygen 17, forming a new nuclide. There were also in the production of protons as well. So this is a human-made nucleus. So this would be curious if you're interested to look up what was the application of this, right? Why did they want to make this? What was the application of this particular nucleus that was produced? So particle accelerators, these are devices that increase the kinetic energies of particles to induce transmutation reactions. So there's like literally a whole field, or maybe I should even say like a field within fields, called particle chemistry, maybe particle physics is actually the name of it, of the discipline, but it clearly intersects with chemistry, right? Chemistry, physics. And essentially they're crashing particles into each other and to induce transmutation reactions, right? Because if there's enough kinetic energy, whatever is in that space is going to start colliding. And then see what happens and study the outcomes and the result of these particles. So there's tons of research using these devices. So CERN is, I think it's in Italy or in Europe. It's somewhere. I'm pretty sure it's in, why do I think Italy? I'm not sure. Fact check me on that. But this is an example of the largest particle accelerator. So let's just quickly, right? You've got the website here, but I just want to venture into the website really quickly, see what we can see. So come to this website and just explore, right? Learn more about what an accelerator is, right? Um, right, as I mentioned, right, they are essentially making particles collide with one another and then observing the outcome. So they also talk about how an accelerator works, the components, the characteristics of an accelerator. There's all types of accelerators. So they talk about the types that are specifically at CERN. So I invite you to venture more into this. And if you're anything like me, I always want to know what the application of something is. Like, okay, this is cool, but like, what does that mean? Like, what does a particle accelerator mean? Or why would we want to crash particles into each other? Okay, new nuclides are formed. What does that mean? Right? What does that mean in life? How is that impacting us? Um, the thought right now that comes up is we can gain insight around how certain particles that we've come to know were formed in the first place. So it can give us insight into that. So it can be more of a basic science question. And then I suppose you can create new particles that might have some really cool applications in like climate or materials or right some application in our everyday world. And so let's see what if we go to science or actually let's go to news. This might give more context to like what does this mean? You can explore here. Like what does this mean in our day to day? Why is there all this funding that goes into building a huge particle accelerator such as CERN, right? And if there is a ton of funding put into it, it probably has some application. I mean, in general, science all has application, right? But what I mean by application, it's probably not completely exploratory. It probably has some application for how it's going to impact our economy in some way, right? Impact our knowledge around something, solve some type of problem. So if you want to know more about the application, come to news. Um, if you want to nerd out, come to the science. This is really cool. The physics is what's really calling to me in this moment. But yeah, come explore this website. Come explore this website. So let's go back. Let's go back. So, particle accelerators, devices that allow us to induce nuclear transmutations. It's like how we do chemistry in a test tube. We might mix some compounds or some solutions, or we might dissolve a solid into a solution and then it undergoes some chemical molecular transformation in that test tube. particle accelerator is where these nuclear transmutations take place. All right. So, two types of nuclear transformations. I'm sorry, transmutations. We can have fission. Fission is where a larger nucleus is broken up or split apart into smaller pieces. This is not usually a natural process, right? It usually involves taking neutrons and crashing them against this large nucleus to induce fission. So here's a schematic of an example of fission, right? We have a neutron here that crashes into uranium-235 nucleus. This results in uranium-235 becoming uranium-236, which um is much more unstable, right? It's an unstable nucleus, which is why it splits apart into two smaller nuclei. And as a result, when it splits apart, now it forms two new nuclides. So you literally go from uranium-235 to uranium-236, which is unstable. So then it splits apart into two new nuclides, krypton-92 and barium-141. This releases a lot of energy, and it also releases three neutrons. So fission is literally about inducing a collision that breaks this particle up into smaller pieces. So you can kind of maybe intuit what fusion would be, right? Fusion is going the opposite. So it's the process of converting very light nuclei into heavier nuclei. So fusing together nuclei. So here's an example where we have four of these hydrogen nuclei. They fuse together and form one helium nucleus and two positrons, which is the main source of energy in the sun, right? So fission, splitting apart, fusion, we're now combining nuclei into another nucleus. All right. Anything else I want to say about fusion? No. So main thing I want you to know here is what what is nuclear transmutation and what are the two types of nuclear transmutations. And also I've given you a couple other things to explore. Let me know what you come up with. If as you go through the CERN website, if you uncover something interesting, do share. Um, And also, if you go on a deep dive of the Dead Sea Scrolls, the Dead Sea Scrolls, or carbon 14 dating, right? Do share there as well. All right, see you in the next video.